Okay, picking up where we left off on page 306, we're talking about RFID tags. And in a sense, I guess that's a type of computer input because, you can have tags on inventory items, you can have tags on equipment, you can have tags on cards and theft prevention, those kinds of things. So moving right along, they talk about magnetic stripe readers, and you know what we're talking about. So I have a credit card or an ID card or something, and it's got this, the black stripe on the back side. And so that's a magnetic stripe, and inside there is a bunch of information about you. And so you know how this thing works. You go to the grocery store, you buy something, you whip out your debit card, and you run it through the reader. And of course, if you have the card upside down where the magnetic stripe is facing you or facing away, it doesn't work, right? So it has to be facing the reader. And so as you move it across the read head, it pulls information off that magnetic stripe. So you guys know what that's all about. Okay, let's continue then. On page 307, they talk about the banking system has a magnetic ink character recognition system. And it's for, you have your check, and then you have at the bottom, there's a routing number and your account number and probably the check number and some other kind of things. And it has a little funky looking letters in it. Well, that's designed to be read by a particular type of reader. It's not necessarily an optical character reader. It's a magnetic character reader. And so what happens is that it basically just has iron oxide in the ink. And what they do is they run a magnet over that, and that temporarily, as it runs through the machine, they run a magnet over it that it turns on the magnetism on the ink. And then they read it through a reader, and they can tell from the pulses of the magnet, what the characters are. And so it reduces the error rate. Optical character recognition has about a 1% error rate. And for the banking industry, that is not good enough. I don't want 1% of my deposits going to somebody else's account, right? Okay, so they want something that's a lot more. So if it got dirty, it got bent, even if somebody took an ink pen, right? So you had a 6, and you went in there and changed it to an 8, right? On the little code, it still read as a 6 because you're not actually changing the magnetic properties. So it's actually not foolproof, but it's more resistant to tampering. So much better error rate and a little bit more tamper resistant. So that's why the banking industry uses that. Cool? Okay. On page 307, they talk about the reading devices, the data collection devices. And just a couple of chapters ago, we talked about source data automation. I gave you the example about how you're a shift worker and you're filling out some sort of a form, and that gets you turn it in at the end of your shift, and some poor slob on the second shift does the data entry, and then the next day you come in and it has all the errors. And so that's not really cool for efficiency. So the same kind of thing exists when doing like an inventory. If I have a barcode reader, handheld barcode reader, I could go to the warehouse and go toot, 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 and inventory everything right then and there. And the chances of errors is reduced dramatically. So the idea is the same concept as source data automation, except now I'm using these little input devices to no data transcription error, no, oops, I was on the wrong row in the warehouse, or oops, I had the wrong part number entered when I counted them, and that kind of stuff. So it's pretty cool. Okay, on page 308, they kind of sort of changed the subject, and now they're talking about output devices. And so you know what we're talking about. There's lots of ways you can display text. You can display it on a screen. You can display it on a printer. And on the graphics, you can have a printed graphic, or you can have something on a screen, audio and video, all these kind of cool things. Okay, so let's talk about it. So output is data that's been processed into some sort of usable form. That's their definition. And bottom line is, it's where the product of the computer, the product of the computer system, typically meets the human. Eyeballs, ears, things of that nature. So if you're meeting the human's eyeballs or their ears, then that's definitely output for the computer. So a display, page 309, the visually conveys text, graphics, and video. And sometimes it's called a monitor for reasons I don't know, because a display, a monitor, a screen, they're all really kind of sort of mean the same thing. It's just all these different terms that have been thrown around throughout the years all mean the same dang thing. An LCD monitor, don't worry about what all that stuff means. It's just one of those flat panel kind of monitors. On page 310, they have some pretty cool stuff. They talk about the quality. So I'm comparing two tablets, okay? And so one of the things I want to know is, what is the resolution? So one tablet has an 800 by 600 resolution, and the other one has 1024 by 768. Well, what the heck does that mean? What that means is how many dots. So an 800 by 600, the numbers are smaller, meaning there are fewer dots on a screen. So if I had a screen that was the exact same size, that had, instead of 800 by 600, had 1024 by 768, the images would look sharper and clearer and a lot more detailed, because there's more pixels, more dots in there to make up my image. Okay, you may recall, Apple came up with this term called a retina display, and it's all about how many pixels per inch. And a pixel is basically one of those dots I just talked about. You have 1024 dots, and that's not actually a very good definition, but for layman, that's good enough. So what does a retina display mean? What it really means is somewhere around 200 to 300 pixels per inch. Now, if I'm holding my phone, 12 inches away from my eyeballs, high resolution may kind of be lost on me, because there's just so much that I can get. Now, if I have a television that's sitting 20 feet away, higher resolution might make a little bit more sense for me. But if it's 15, 20, 30 feet away, I will probably not be able to tell the difference between a 720p video and a 1080p video. If I'm 30 feet away, I probably won't be able to tell. My eyeballs ain't that good. So it's a matter of pixel density and depth of how far away the device is. If I'm holding it really, really close, then yeah, retina display might be pretty doggone impressive. If it's across the room, retina display may be a waste of my money. Okay, so resolution in dots, response time. Some displays are just slow to make changes. So if I had, for example, a black screen that switched to white and then switched back to black, switched back to white, and how fast could you switch them back and forth before it just turned into a gray blob, right? So gamers like monitors and displays that have very fast response times, so that the motion in their game doesn't blur. It maintains sharp crystal. How much brightness there is, particularly in a handheld device. There are some devices that when you take outside in bright sunshine and you cannot see. Okay, you might have to hold your hand over like this, trying to see what the heck is going on. Others have a bright enough screen that you can actually work on them outdoors without having to shade them in the bright sun. So dot pitch is another way of saying pixels per inch. Same thing, just different terms. And then the contrast ratio. This is the ability to show the fineness between black and white. How dark is the dark? Because on some televisions, for example, when you have a black screen, it's not really black, right? I mean, if you turn the light out in your house, right, and you had nothing but a black screen on TV, how much light is coming out of there? Well, quite a lot, actually. You can light up a room with just black being shown. So how black is all about what the contrast ratio. So you want very high contrast ratio so things look really crisp. Okay. So they talk about the displays that are available today, and almost all of them are digital now. You can barely find an analog display nowadays. They may have an analog port, but it's all simulated. So a DVI port on your monitor, digital video interface. And so it's basically just the old, instead of using an analog signal being sent across the wire, they send digital signals, and then the monitor itself processes whatever it needs to do. Okay. HDMI, high definition media interface. HDMI was part of a digital rights management initiative so that people would display copyrighted materials that had to have a complete copyright path all the way through, so you couldn't, the encryption had to be all the way point end to end, so you couldn't put a device like in between. You couldn't have a video player, a television, and then put a video recorder in the middle, as an example. It turned out not to be all that much to do with digital rights management anymore. But HDMI is all about high definition digital. And they have another one out that's called DisplayPort, and they're essentially the same thing, except DisplayPort was kind of trying to be a little bit more backwards compatible for the old analog. And then there's another spin-off of DisplayPort you've probably heard of called Thunderbolt. And Thunderbolt is designed to tap a little bit deeper into the guts of the computer, to tap in to, instead of tapping into the peripheral expansion bus, it actually taps into that other bus we talked about from the previous video, where it taps into that backside bus, which is much, much faster. Okay, so DVI, HDMI, DisplayPort / Thunderbolt. And those guys can get physically small. One of the problems with HDMI at the beginning is the connectors were relatively decent size, and if you had a small phone, you probably were not going to put an HDMI port on a phone. You just physically wouldn't fit. So they end up with this miniature version, a miniature display port. They even have a micro display port that they're still working on the standard for. Okay. A lot of people use their television set as a monitor. Yes, you can. These videos that you're watching right now through YouTube, you could, if you had the right kind of equipment, watch these videos through the internet on your TV. Cool, it works. And of course, the HD TV is the most prevalent. That would be the most appropriate for a high definition video like this one, is to watch it on a high definition TV. Smart TV, those are just TVs that are automatically connected to the internet. A lot of people don't have necessarily a smart TV. They have a smart, Blu-ray player, or they have a game console, or they have, one of those other type of internet connection devices, a Roku device or whatever, where you pull content down off the internet, and so it makes your TV like a smart TV. Okay, on page 312, now we're kind of changing to printers. And you guys know what a printer is, for goodness sakes. It just produces, text and graphics, and in some cases, photographs. It works pretty cool. Almost all of the printers nowadays are what's considered a non-impact printer. In the old days, you had a ribbon, right, like a typewriter, and you had these little pins that would poke through the ribbon and make marks on the page. Those are practically unheard of in a home environment now. So the non-impact printers, inkjet printers and photo printers and laser printers. There are some thermal printers out there, like, for example, cash registers typically have things like thermal printers, and they use specially coated paper, and instead of ink. That way you don't have to worry about running out of ink in the middle of something. They have mobile printers and things of that nature. Let's kind of continue. So inkjet printers are the ones that are the most prevalent these days. You guys know what I'm talking about. So inkjet has a series of colors, and so they have this, this cyan, this yellow, this magenta, and a black cartridge. So almost all inkjet printers have at least 4 cartridges, and the 4 cartridges are really designed to do modest amount of graphic work. Now, not necessarily photography. So a 4-color inkjet printer is great for doing a PowerPoint presentation. It's great for doing line art and clip art. But, your family photos, probably not. So we'll continue this discussion in just a few.